Okie dokie. Yep.
Let me push this button also. Okay, there we go. I have something prepared here. There you go. Yeah, so welcome and nice to see everyone here. We have only one speaker. Unfortunately, Wim had an injury using a smoke cannon. I have absolutely no idea why, but yeah, he got injured and wasn't able to make it. So we only have Peter Fisher today here with us. Um, I already heard his voice. It sounds perfect. He's also a professional podcaster. So he has all the right equipment. So it's going to be a beautiful sounding experience. And yeah, coding with confidence is something that we can all um, do better. So I'm very eager to see this presentation. Uh, at the end of Peter's talk, we have closing notes and a raffle. And then we go to the breakout session where we can have further discussion on PHPStan or PHP or anything that the PHP community is always worrying about. A small shout out to all the local user groups that we represent. Uh, there have been tough times, but I see a couple of these user groups ramping up again with in-person meetings. So I'm very excited to see everyone in person again. Yeah, let's have a look out on all these meetups. So the first speaker will be Peter. He has, by the way, Peter, the BSc MBCS. I'm not familiar with these abbreviations. Will you care to share something about this?
It's the British Computer Society.
Oh, okay. All right. Well, there you have it. Of course, this meetup was not possible without the sponsors. Longtime sponsor Spatie is here. We also have our new sponsor IO, IO Digital, and they're basically the rebrand of Interacto. So for those who have heard of Interacto before, they're now called IO Digital. Yeah, I'm very excited to see the rebrand here. Because yeah, IO delivers elephants, so we're going to raffle elephants at the end. So I'm very excited about that. That's it from me. Now it's Peter Fisher's turn. So Peter, take it away. We will keep the questions up till the end. So you have the floor.
Thank you very much. And it's a pleasure to be here. Today, we're going to talk about code with confidence using PHPStan. Right, so let me move on to here. So, right, this talk is broken down into 4 sections. So the first section is to discuss what does code confidence mean to me? And then we're going to talk about static analysis, generally speaking. And then how to install, run, and configure PHPStan. PHPStan being the static analysis tool that we're going to be playing with today. And then I'm going to bring everything together in the 4th part and talk about how we can increase our code confidence using this wonderful tool, PHPStan. So before I get into any of that, though, just a little quick thing about who I am. So my name's Peter Fisher. I'm a PHP contractor from the UK. And I've been playing around with PHP for over 20 years. I'm also the host of How to Code Well because I'm very passionate about teaching people how to code and how to code well. I have a podcast that runs every week. It's howtocodewell.fm, and there is a YouTube channel as well, which is youtube.com/howtocodewell. I also live code on both YouTube and Twitch, and the howtocodewell.net website has my courses and tutorials that I've created over the years. The courses and tutorials, they're all sorts of things from PHP to Linux to Python to JavaScript and all sorts of other bits in between. You can get these slides from my blog, which is peterfisher.me.uk, slides and code with confidence using PHPStan. I will be updating the slides based on various feedback, and I have done over the past few talks that I've given. So let's get into it then. What does code confidence mean to me? Well, in my opinion, and this is my only opinion here, is that there are three types of projects that every programmer will deal with during their career. The first particular type of project is a new project. This means that what we're going to do is start from scratch. So we have no code. We don't have anything to begin with. Therefore, we don't have any architectural decisions. We don't have a framework or a library. Nothing's been chosen yet. We don't have a bugs list because there's nothing in existence. We probably have a couple of people wanting to use this application or a market for the application at the very least. And we probably have a shopping list of requirements that we need to meet. And those requirements probably come with a series of time constraints to do all those things. The second project is a legacy project. Now, this means slightly different things to different people. And a legacy project can be in different states. So, for example, you could be working on a legacy project that is spaghetti code. So lots of messy code, lots of issues to uncover. It could have a mixture of frameworks within this legacy project. So, for example, it could have many different versions of jQuery, for instance, or it could have other JavaScript type frameworks for the front end. It could also have different frameworks for the back end as well, or it could have a framework alongside sort of a homegrown type affair framework. These frameworks, these libraries, these extensions that we're using could also be at very different levels of different versions. And therefore you could be battling against all sorts of different security issues or any kind of upgrades and dependency issues as well. Because it's a legacy project that is probably in the wild, you're probably going to be dealing with existing users, and those existing users, or some of them at least, might be complaining. You may have a bugs list, and you'll probably have a bunch of unknown issues, so unknown bugs. In my experience, not all legacy projects are tested well. So you might have 0 tests or just a load of flaky tests. In my experience as well, not a lot of them have very good documentation, or the documentation that they have got isn't as up to date as it should be, and therefore it's quite a challenge to set things up and get things rolling. You could have, like I said, many end users, and some of them could be upset and complaining and requesting new features. And you yourself as a developer who's come onto this project could have, therefore, low confidence that any of your code that you're writing will integrate well with the current set of code and be able to do the thing that you want to do. This gives me a low confidence level. The third type of project that developers will probably play with within their career is a migration stroke rebuild. Now, this is where we take a legacy application and we want to migrate it from one thing to something else, from one platform to something else. I've done lots of this in my career. This could happen due to data integrity issues, performance issues, security issues. There could be an issue in terms of the library or the version or the framework that you're dealing with is gone into a completely different direction. And so it's actually taken out of your hands, the decision to do it. You have to do it. With a migration stroke rebuild, what we want to do is take care of downtime. We want to make sure that everything is nice and smooth, and the end user isn't terribly affected by this. Because we're doing a rebuild, we probably have a bunch of workarounds that are already in people's minds, probably not written down if it's a legacy thing. And therefore we need to cope with those workarounds and discover what they are. Okay, so that sounded a little bit sort of depressing. So what is the dream? Well, for a new project, what we want to do is start clean, continue clean, whilst building up confidence with the code. We want to be aware of the known issues before the very first deployment. So we want to be aware of any gotchas, any silly mistakes that the code has before it goes out in deployment. We want to gain visual feedback on the parts of the code that need to be fixed. So we want to actually see those pieces of code in perhaps a report, this is a risky piece of code. We want to spot potential gotchas when we're creating new architecture. So we want to spot, we don't want to find ourselves coding in a rut. We want to make sure that the code that we write is actually going to be able to be shaped in a better sense in terms of code extension, extensibility, and all of that jazz. We want to create a continual integration pipeline to ensure that our team and us are working to a given set of rules and standards. And essentially, in a new project, the dream is to move quickly whilst building stability. For a legacy project, we want to quickly identify issues whilst building up confidence with the code. So this project is already in existence. And so we want to, as a new developer on this project, we want to uncover any code smells, any issues that the code has. And we want to be aware before we actually start writing new features on the existing code base, that the things that we write integrate well with that code base. We want to going forward, we want to enforce code standards and rules in our continual integration pipeline and standardize the code base going forward. This will essentially make our developers on our team happy. And for a migrated project, what we want to do is to ensure that the migration is as smooth as possible with as little disruption. Our end users should only be experiencing positive changes during a migration. And we want to be aware of the risky areas before we do any deployments. Essentially, when I think about code confidence, I think about this thing here. So the dreaded 3 a.m. phone call or Slack message on a Saturday afternoon or Saturday morning after a Friday production deployment, versus knowing that your code and everyone else's code will get checked before it goes anywhere near production. Okay, so that sounds great, but how on earth do we get there? Well, in our toolbox, we have various different tools that we can play with. We have PHP mess detection for cyclomatic complexity checks. We've got code sniffers and linters and all sorts of different things to check that our code conforms with a given set of rule sets. We also have, obviously, PHPUnit, and that will check our code meets the requirements that have been set out. And of course, you've got acceptance tests, integration tests, and all of that other good stuff. But we also have static analysis, and we can add this to our toolbox. So what is static analysis? Well, I pulled this from Wikipedia. It says static program analysis is the analysis of computer software performed without executing any programs, in contrast with dynamic analysis, which is performed on programs during their execution. Okay, so what does that mean? Well, static analysis will search the code for non-coding compliance without the need for you to actually execute that code. It compares the code against a given set of rules, and it tells you which file, which line doesn't conform to which rule. And it also, in some cases, PHPStan, for instance, it also offers you a suggestion as to what you should be doing to fix that. In short, it prevents very bad things from happening. But what is the point? Well, PHP's type system it runs at runtime, right? So you have to get to the point in which the error is thrown in order to see the error. So let's say, for instance, you have created this feature, and this feature has a series of forms that the user has to go through, and it gets to the end part of the form and it falls over. Well, for you to test that, for you as well as, say, the QA engineers and testers to get to that point, they would have to go through all of those forms in order to get to that failing point. And this means that you need to have a user account at a particular state and all of that other stuff, all the dependencies that are required for you to actually set up the test and get it to that point. And if the failure is based upon, say, a type system, or you've gone and so you've given a wrong type, for instance, to a method or whatnot, all of that can be captured at static analysis. So the code needs to run at the point of failure before it's being discovered. And you need to actually get the code to that point in order to see the error and get the log. And a bug found at runtime will always cost you more than a bug found during static analysis. And the word here, cost, it doesn't just mean sort of money, although money is certainly a factor here. It could cost you reputation. It could cost you a sale. It could cost you all sorts of time. It just, to get to that point, setting all that test up would cost you time. So if you could find bugs before they actually happen, before it actually gets into deployment, before it gets put in front of your users, then that is a win. So type checking, I've just mentioned that a couple of times. This is an example, and yes, I have seen this in the wild. We have a variable here, and we are instantiating a new standard class, but this standard class, we're adding 5 to it, and then we're echoing out the variable. So we're actually getting a type error here, unsupported operand types. And if this is out in the wild, then obviously this is going to throw an error, but this could be captured at static analysis time. Now, you could be thinking, well, okay, Pete, that's great, but I can refresh the page and I can actually see things working. And that example that you've given of, a user going through a series of forms, well, I've tried that in my test and it works. And I've actually created sort of a testing suite that does all of this. That's all well and good. But my argument is that, yes, that could be running in that particular state, in that particular user's account, but it may not be running for all of your users. So just because you refresh the page, you being just one of you, doesn't mean that the other 100,000 users that have very different account types and different variables being thrown around in the code at any one given time, one of those may be failing. Also, your code might not be future proof, and PHP 8, we're moving into stricter types here. Your code might not be working very well with your libraries and your dependencies that you're using in the future, and you may have a hard time moving your PHP 5.6 application all the way up to PHP 8. So PHPStan has entered the chat. PHPStan, the tool that we're going to use, PHPStan is, you can get the documentation at phpstan.org. It is a free and open source application or utility tool. And it does have some pro paid features too. Okay, so let's talk about how we can install it. So composer require --dev is what we need to do. The package is PHPStan, and the reason why we're giving it --dev is because we want to have this in our development machines. We do not want to have PHPStan anywhere near production, because this should all be checked at development time and testing time. It shouldn't be in your production environment. This is an example of the first run. So we're running vendor bin PHPStan. That is our command. We're giving it the argument of analyze, and we want to pass a path, which is src. So this is going to analyze with the defaults, the path src. Okay, so this is an example of when things go well. So what we've done here is we've ran 293 checks. 100% of them have gone through, and we have 0 errors. Brilliant stuff. So this is all good. This is on a normal output would be nice and green. Okay, so this is what it looks like when things don't go so well. So what we've got here is we've ran our 293 checks. That's all good. However, one of those checks has thrown an error. And we can see here on the left-hand side, we have our line number. So on line 84, we also have the file name, which is downloader code downloader.php. And we have a description of the error with a suggestion as to how we should fix it. So method app downloader code downloader get file name should return a string. So it should return a string, but it's actually returning a string or a null. And this is being picked up via PHPStan using static analysis. So this is the code in question. So what we're doing here is we've got a method get file name. And as you can see, we should be the definition, the native return type here is a string. So what we're doing is we're returning the get file name from get code from the course object. But as we can see, what we're doing is we're only returning get code if there is a course, and we're only returning get file name if there is a code, hence the question marks. So this is actually going to return string or a null, and the fix here is to pass in the question mark, so question mark string as the return type. Okay, so at the time of this recording, there are 10 run levels between 0 and 9. However, this may change through time. And each run level changes the strictness, so it gets more stricter the more you go up the levels. Level 0 is used at default, and I'll talk about what that means in just a second. And running a level higher than 0 will run all the levels before it. So for instance, running level 5 will run 0, 1, 2, 3, 4, and 5. Now, if I was to go through what each level does, we would literally be here all night because they are incredibly thorough. But what I'm going to do is just give you a rundown as to sort of the high level checks. So level 0, which is actually quite a thorough set of checks, does basic checks, unknown classes, unknown functions, unknown method calls on the this variable, wrong number of arguments passed to those methods and functions, and always undefined variables. So level 0 is actually really difficult to get through when you've got a legacy application and it's just riddled with all sorts of interesting things, shall we say. Level 1 is a possibly undefined variables, unknown magic methods. Level 2 is unknown methods checked on all expressions, not just this. Level 2 also validates PHP docs as well. Level 3, return types and types assigned to properties. Level 4, which is amazing, level 4, dead code checking, which is brilliant, and unreachable code. Level 5, I won't go through all of them. Level 6 is missing type hints, and all the way to level 9 is being more stricter on the mixed type, which is very difficult to get to. Okay, so how do we run this then? How do we run this at various different levels? So what we do is we pass in the -l. -l is the argument, so level, or we could use --level equals and then the level that we want to run. In this case, we're running 5. So remember, it's 0, 1, 2, 3, 4, and 5 to get to. If we wanted to, we could ignore code. So within our code, we could say, hey, PHPStan, just ignore this line. So here we have 2 examples. We've got the first name and last name. One would assume these would be strings. So in this class, these would have the type hint of strings, but they don't. So what we could do is either ignore the actual line, so ignoring the current line that the comment is on, or we could ignore the next line if we wanted to. We could also use double slashes as well. We don't have to use the asterisks. Okay. So configuring PHPStan is pretty awesome. There are various ways to do this, and it's incredibly flexible. It uses the neon format if you're using the configuration files, but you could also configure it through the CLI. Now, the neon format is pretty cool. We've got phpstan.neon or phpstan.neon.dist. This is an example of our neon file. It's very similar to YAML. So what we have here is we're saying we want to run it at level 6. This is our parameters. And we want to pass in an array of paths that we want to test, so src and tests. But the really interesting thing about PHPStan's configuration is the order in which it goes through in order to use the configuration that we supply. So, for example, we could pass in a configuration file using the -c argument. If we don't do that, and if phpstan.neon exists, then that will be used. Otherwise, if phpstan.neon.dist exists, that will be used. And of course, if none of that exists, then it's going to run through defaults. The beauty of this means that what we could do is put our phpstan.neon.dist in source control, allow that to be used by our continual integration pipeline, and let the developers use their own phpstan.neon, ignoring that from Git. This means that our developers can override the settings in our continual integration pipeline, allowing them to test, say, future levels or, ignore certain errors and whatnot as they're developing. And I'll talk about more of that in a mo. Okay, so we could also, within the configuration file, include other configuration files as well. So phpstan.neon.dist here, as well as a test file. This is an example of supplying paths. So again, using testing src and tests. But we could also do this through the command line by just saying src and then space tests after the analyze command. We could exclude files. So this is a way of excluding a pattern of files and directories. So we use our exclude paths parameter. And if we really wanted to or really needed to, we could ignore errors. So this is a regular expression saying that we want to ignore the error function PCNTL_open not found, and the hash symbols either side. That's our regular expression delimiters. So if we wanted to, we could supply an array of errors that we wish to ignore, and it's going to ignore those errors from our entire code base or whatever paths that we've supplied. Now, there are far more configuration rules to use, and we would be here all night if I went through every single one of them. I would literally be just reading off of the documentation. So you can find it at phpstan.org config-reference. Okay. So let's bring this all home and talk about how to increase our code confidence using PHPStan. I've mentioned why we should be using static analysis. The best thing that I think has happened in PHP in a long time is static analysis, and how to configure and install and run PHPStan. But really, how is this going to increase our code confidence? What I've done is I've split up the various different types of projects that I mentioned at the start of this talk, and I've given some recommendations as to how to use PHPStan with those different types to increase our code confidence. We're going to start, though, with recommendations for any project. So any project, regardless of whether it's a new project or a legacy project or a project that is yet to be migrated. Okay, so the first thing is that we want to create our continual integration pipeline if we haven't done so already. But the order in which we do this is incredibly important. The first thing one should do, in my opinion, again, this is just opinion, this hasn't been laid down into some sort of gospel fact thing, this is just my opinion. First thing to do is PHPCS, so this is checking for code standards. PHPCS can also be used for various things like security audit checks as well, which is awesome. But we want to do that first because this is going to tell us that our code conforms to a given set of rules before it even gets checked by PHPStan for static analysis and PHPUnit. We could also have other things in here. I've mentioned PHP mess detection and other bits and pieces too. But PHPCS, then PHPStan, then PHPUnit. The reason why PHPStan is in the middle is because PHPStan, the errors that are thrown will direct us into possibly how to refactor the code. And if we were to refactor the code after we've ran PHPUnit, we would invalidate our code tests. So what we should do is run PHPUnit at the very end. So PHPCS, PHPStan, and then PHPUnit. Another thing to do for all projects is to have one single command that runs them all. So I used to be a massive fan of Makefiles. However, when I switched to various different platforms, that became less of a thing that I like to do. So what I would do when I was using Makefiles is I would have like make stan for static analysis, make unit for unit tests, make CS or lint, and then I would have a single make command that would run them all in the order in which I've just mentioned. Also, you could create a composer rule as well, composer script, and do those. So composer test would run all of that thing in parallel, or not parallel, in the order that I've mentioned. And definitely use a CI, and the commands that you allow your developers should be the same commands as what your CI uses, because they need to run those, in the same way as your CI to replicate those issues. Okay. So again, this is for all projects. So only test your code. Don't analyze code that you haven't written. Don't worry about the vendor directory. And also don't worry about code that has automatically been generated for you. So for example, migration files. If you try and test those and you run commands that automatically generate you more code, then you're just going to get into a circle of annoyance when you're having to fix the code that's already been that's being generated for you. I've been in it. It's a mess. Don't do it. It's going to waste your time. Just ignore it. Just put that into your exclude paths. What you also want to be careful with is upgrades. So I've been caught out by this. What you want to do is you want to run PHPStan before an upgrade. And when I say upgrade, I mean an upgrade of a framework version or an upgrade of PHP itself. So run it all before, so you've got an idea as to how many errors are being thrown and whether they're acceptable errors. And I'll talk about those in a second. Because what you want to do, or what happens when you do an upgrade, you'll probably end up having more errors, right? So you're just going to add to the pile. And by fixing the errors before the upgrade, it's going to make your upgrade a lot smoother, a lot simpler as well. Okay, so after your framework or PHP version has been changed, run PHPStan as well. And also after upgrading PHPStan, so composer update and then PHPStan, you want to also rerun PHPStan. The reason being is that you'll probably get more checks being put into your application. So you want to make sure that you are always aware of the state of your application. Also, look at your composer.json file and find out the extensions or the things that you're using. There will be, or there could be, extensions for PHPStan that has their own set of rules that you could hook into. So for instance, there's an extension for Doctrine, there's an extension for Symfony, there's all sorts of other extensions for other bits and pieces. So make sure you have those extensions installed. Okay, so they're recommendations for any project, but let's now drill into and focus into recommendations for new projects. So projects that are completely box fresh. Okay, so what you want to do is try and avoid as much as possible in excluding any code. So ignoring lines of code or excluding paths of code that you're actually actively developing against. The reason why you should be careful and cautious, especially around a new project, is that often configuration that has been created around the ignoring rules and excluding rules, they often get forgotten. So it's one of these set and forget type things. And you may create the exclusion rules and then leave the project. And then another developer will get to it. And then before they know it, they're actually writing code that is not conforming well, but it's been excluded. And so it just turns into a mess, really. So try not to ignore or exclude anything when you're starting out. Also, you want to run at a maximum level possible. So here we've got -L here again. This is the level, that the argument that we want to pass. But this time, instead of giving an integer, we want to give it the string of max. This is going to constantly run against the maximum level that PHPStan can offer. And again, I've got an example here of how to do that in configuration. This means that whenever PHPStan gets upgraded, you are constantly using the latest and greatest set of checks available. And really, you want to be doing this in a new project. It's very difficult to do this in a legacy project until you get to that point. But once you are at that point, you should stick with max. Okay. Also, there are ways, if you wanted to get even stricter. So here we've got PHPStan strict rules, and this is an example here on screen of how to include those rules. So we would use the includes directive here, or if you've already got extensions installed in your PHPStan, you're probably using the extension installer. If so, this will automatically be added for you. Okay. What about legacy projects then? What about legacy projects that are already out in the wild? People are using them. People are relying on them. How do you go about using PHPStan? This is a bit of a tricky sort of shape. So here we go. What we want to do is fix errors in a separate branch. Again, I'm talking from experience. It's embarrassing to say this, but there has been a project where I have created a feature branch for this thing that a client wanted, and I had a little bit of time, which is very rare, obviously, where I thought, okay, why don't I go ahead and just run PHPStan and fix a bunch of stuff? And I fixed a bunch of stuff in a feature branch. Well, a week went by, and all the code was ready. Everything was going out to test. And then the feature branch got canned because, well, this could happen for all sorts of reasons. The client could go in a very different direction, could have a different way of thinking. There could be a budgetary issue. There could be all sorts of stuff. And so I was left with a feature in a branch, as well as all the fixes for PHPStan, or a lot of fixes, shall we say. And I had to end up unpicking that branch to create another branch that just held all of the fixes. So try and separate things from new things or upgraded things to fixes. I guess this is 101 of code, really. Okay, so ensure that you also have the correct support packages and libraries installed, the extensions that I mentioned for a legacy project. So if you've come in and to a project and people are talking about PHPStan or static analysis, spend a bit of time going through your dependencies and seeing what extensions need to be installed. Also, what I would do is run at the very highest level once. Just do it once. This gives you an idea, a shape of the errors of the project. And this is incredibly useful when you're fresh to the project. So this is a legacy project for you. And this will give you patterns in the code. So you may spot a bunch of errors that relate to a similar set of files or namespaces, or a method might be mentioned quite a lot of times. So as a new developer coming onto the project, this is actually quite an interesting way of getting an idea as to the shape of the project and how it's created. I was going to say how, yeah, I was going to use another word, but how it's created, shall we say. Okay, so this shows you what you're up against. Don't be afraid of the number that you're going to get, the error number here. I've ran this before in legacy projects, and no joke, tens of thousands of errors. Save the number, keep that number, because that's the number to beat, I guess, if you're trying to do this in a competitive way. But keep a note of how many errors you've got. Also, before I go on to the next slide, this is actually a good thing when you are trying to sell to the client that you need to migrate or rebuild. So moving from one platform to another platform, because this is a great way of saying, hey, all of this code needs to change before we upgrade to this. This is my justification of why it's going to take this amount of time. Anyway, so start small and go gradually. So once you've ran at the highest level, then take it all the way back to level 0 and start incrementally going up the levels. Do this very small and go very, very gradually. Do this one level at a time. Each level is very different. It's got a very different set of checks. It's going to throw all sorts of different errors. And you'll expose all sorts of different interesting parts of your application. And as I mentioned, static analysis often implies areas of your code that you need to refactor or even re-architecture. So there could be time, long pieces of time before you go up the levels. So don't worry that you're on a very low level, because you'll get there eventually. Okay. Make sure that you have tests to back up your changes, because as I've just mentioned, you may have to re-architecture, you may have to refactor, you may have to do all sorts of things in the code in order to make it compliant against the level that you're trying to achieve. But if you're in a legacy application, you want to make sure that there are tests against those areas of code that you're playing with. This is why sometimes it can take an awfully long time to go up the tests, to go up the levels, because you're having to ensure that there are tests to back up your changes. And these tests, of course, they could be unit tests, acceptance tests, and whatnot. Just make sure that you have something automated to say, yes, that's good, that's good. Okay, so I've come up with 3 confidence levels for legacy projects. You can probably tell that I spend a lot of time in the legacy land. So these are 3 confidence levels that I've come up with. Number 1. Now, this has never ever happened to me ever. So PHPStan is always running at is already running at the highest level and is working well, and therefore there's high confidence. This has never happened to me on a legacy application yet. I can't wait until it does. So level 2 is that PHPStan is installed but is running at a very low level. This gives me a low confidence level. And the question here is, how do we upgrade PHPStan on a legacy project? So what I would do is I would use phpstan.neon.dist, that configuration file. I would put that into our CI and give it a given level to run at and get all those errors to pass. Done. Okay. How do we move it to the next level? How do we get to the next point? Well, I would use phpstan.neon, which is ignored from Git, to then increase to the next level and see what errors are being thrown there. That means that I can fix those errors without interfering with our CI. And also, this could happen because the team isn't aware that there is another level. Right, so you want to mention this to your team in your daily stand-ups. And as I mentioned, try and attempt to do this, these fixes in a separate branch, and try and do them sort of within the sprint. So see if you can get some time in your sprint to just fix up the code. And essentially, it's a case of rinsing and repeating. This is a very long and slow process in some cases. So the last confidence level is that PHPStan is not installed. It's just not installed at all. And you know, you're flying blind, essentially. How do you install PHPStan on a legacy project? Well, this is This is often because the team that you're working on isn't aware of static analysis. And if that's the case, then please do share these slides. Again, run at the very highest level. This is an important point. Generate a baseline level. And I'll talk about that in a second. Generate a baseline level. Put the fixes in a separate branch, PR, and then rinse and repeat until you get to an acceptable level. Okay, so baseline. What is that? What is the baseline? So the baseline is great for legacy projects because there's obviously already code there. And if you're not running static analysis, you have no idea as to the errors that are currently in play in your application. But you could run at the highest level, and you could find that you have tens of thousands, hundreds of errors, right? And you could go to the person in charge and say, look, these are the errors. This is what PHPStan has reported. There's going to be a conversation about time and estimation and effort and energy and all of this jazz. And there's probably going to be a bunch of people saying, well, you know, we refresh the page, it's going to work, it's fine. You know, we can actually see it. We can see it on our screens. The current state. And then that in the future, we're going to include into our configuration. This baseline file will include all of the errors that have been found from this level 7. And then what this is going to do is ignore all of those errors going forward in the current places, which means that we can now get on with our new code, and our new code must conform to the levels that we want to use, which is great because eventually the baseline will start to get reduced because the code that you're writing will end up using code that the current code base stuff that's already in the baseline, and you'll be slowly making that baseline smaller and smaller. Okay, so I also would like to talk about generics because in my opinion they're awesome. And I have a little challenge here. Loop over an array of products, getting the ID of each product. It sounds incredibly easy, right? Everybody's done this. So loop over an array of things and get the IDs out of them. What happens if this is your array? So you have an array of 3 objects here. So pre-order, subscription, and product. But hey, we have a string, we have a SKU, a product SKU. So how do we get the ID from all of this? Well, you may have seen in legacy applications lots of these checks. So here we're saying if it's not an instance of product, if it's not an instance of subscription, and if it's not an instance of pre-order, then we continue. And therefore, we've skipped the string. And now we can get the ID. Well, this can become quite messy. This is also an example of how to do this within a function. So like a method here, so get product IDs. Because we're not giving any definition as to what this array should contain, we then have to do all those checks within this method here. This means that we don't have great data integrity, and it's not great to read because as a coder, when we see an array, we know that that's going to be a collection of things, but we don't yet know what those things are. This can lead to messy code because we're having to do all sorts of checks left, right, and center. It means that our code isn't readable, and it's because we have to put in all sorts of checks. There's going to be lots of mistakes being made. Okay, so the way around this is to use generics here to say that we are defining what is in this array. So we have an array of products, and it's either going to be a product, a subscription, a pre-order, or a string. So we can flip that check on its head. Because we know exactly what should be in that array, we can then check for the thing that doesn't have get ID, which is a string. So if is a string, we continue. And therefore, we know that anything beyond that if statement will be either a product, a subscription, or a pre-order, and therefore we can get an ID. This is fantastic for auto-completion and readability. Ideally, this should be an interface, sure, with a get ID method, fine. But I just wanted to use this as an example of how we can use generics as a means of reducing the amount of checks that we've got in our code. So when should we use annotations, and when should we use native type hints? Well, it's really down to you, but I've got an opinion, and I'm talking, so here we go. Don't double up. Use native type hints where possible, and use annotations when you can't use native type hints. So here's an example. What we want to do is get the items, and I've flipped the integer and the string values around. So we've got a key of a string, and then we've got an integer as a value here. That's great, because what we've got is a native type hint of an array that we're returning, but we're describing the contents of that array within our annotation. Fine. But in this case here, what we've got is a get name function, and we're returning a string. Now, in my opinion, and this is just my opinion, there is no need to add anything else to this to say that this is a string, it's going to return a string. There is no need to have any annotations here, because we can see that it's a string. And if we were to add any annotations, it would just say return string. So don't double up, essentially. Now, if none of what I've just mentioned about static analysis has sold you, this might. So static analysis could actually save you money. So if you're relying on things like Bugsnag or Sentry or other tools, and Bugsnag and Sentry are fantastic, I'm not hating on them at all, they're great tools, they're brilliant, I've used them a lot. But if they are returning you the same errors that you would get from static analysis, then in my opinion, you're doing it wrong, because you're waiting for the errors to happen before you're actually checking statically if those errors are actually in your code. And some of these tools, they rely on the amount of events being fired as to how much money they charge you. So again, if you can reduce the amount of events being fired or captured by these tools, then you could potentially start saving some money. Thank you very much. I've been PFWD, which is my Twitter handle, or you can get me at How to Code Well. Thank you ever so much. It's been a pleasure.
All right. Well, thank you very much.
It was a very nice talk. There was also a lot of discussion on the chat. Let me see if there are any questions. So stick with us. There was a comment by Mark. Let me see if I can pin it. Sticking with Max is all very well, but we used Max until we needed to make the library support PHP 8.1, and that triggered too many errors that I had to dial PHPStan back a level. How far or how well is PHPStan supporting PHP 8 at this point?
Wow. That's a good question. I think it's quite well. However, I must put my hand up and say that because I'm running in legacy land,